data structure to ADD. Okay. So what is the queue? What is the queue? Where we stand in queue daily? Yeah. In SRM we stand in before the lifts. Okay. In public places. In public places. Yeah, for railway tickets. Then in airports, stand for checking visit running. So many real life situations we can model using queue ADD. So how many ends will be there in a queue? How many ends will be there? One end or two ends? In one end you will be entering, in another end you will be leaving. So the same we are going to see as the data structure, queue data structure. So see the diagram. This is a queue line. So two ends are there, one end for insertion. So insertion operation in a queue is known as NQ operation. Similarly, when you leave from the queue, that is another end. So that is known as the DQ operation. Deletion from the queue is known as the DQ operation. And the two ends will be denoted by two pointers, front and rear. Okay, rear pointer for insertion or NQ, front pointer for deletion or DQ. Okay, so it is the linear data structure, just like stack. You can store homogeneous data, items, and how to represent queue. How we can represent queue? Usually, any data structure we can represent using two things. What are the two things? Arrays and links. So we know the plus and minus of both the implementations. Okay. So first we are going to see about the array implementation of the queue. So what are the advantages of array implementation? Static memory allocation, that is advantage or disadvantage?
Disadvantage.
Disadvantage. Static means the size is fixed, you cannot change, you cannot increase the size of the array during the runtime. Okay, then there will be memory wastage when the array is not full. Then what about the advantages of array? Easy to access. So random access is possible. You can access any element to the array directly. Then what about insertion and deletion?
You can manipulate easily.
Insertion and
Easy.
deletion. Will it be easy or difficult?
Easy.
Easy. Easy in array?
Easy relation.
Difficult in array. Why? You want to insert it as the fifth element?
We need to
You have to literally go all the data before the fifth element or after the fifth element. You have to create space for the fifth element to be placed. So insertion and deletion will be
Difficult.
time
Consuming.
consuming in arrays when compared to linked list. So whatever the plus in arrays, that will become the minus in linked list. Whatever minus in arrays, that will be the plus in linked list. We will see the array implementation first of all. Let's see the array implementation. The size of the array is declared as n. Front pointer, rear pointer. Initially, when the queue is empty and there are no data in the queue structure, where will be this front and rear pointers will be placed? Front and rear pointers will be placed in front of the queue. That is before the queue. Okay. So when the queue is empty, the condition is front equal to 0. Rear is also equal to 0. You will start the index from 1, not from 0. Okay. If I start the index from 0, then front and rear will be equal to minus 1. Okay. When the queue is full, all the elements in the array will be placed 1 or n. So when the queue is full, the rear pointer will be at rear pointer for insertion. So it will be at the nth element. Okay. The front pointer will be at the first position. Then that means that the queue is full. Suppose you are having some elements in the array and some elements are missing. How will you know that? How can you say that the queue is not empty? So whenever front is less than or equal to the rear, I can say that the queue is not empty. Okay? And then see, how will you find out the number of elements in the queue? Rear minus front plus. So take note these things. For the queue implementation. again for front and rear pointers, I am going to use Riya and Piyush. So Riya, you want to be front or rear? Front. So Riya is going to act as the front pointer. She will always point to the
Front.
data, which is going to be
At the first place.
front end for which operation? Insertion or deletion?
Deletion.
Front end for deletion. So she is always address the data that is going to be deleted. Okay. Piyush, she is going to act as the rear pointer. He will always address the data that is going to be inserted into the row. Okay. So initially, see, this is going to be the Q. Two ends are there. Okay. Two ends are there. One is the front end, another one is going to be, sorry. One is for the data entry, another one is for the data exit. Okay. So initially the queue is empty. So what is the size of the array I am going to declare? Can I have 5? So 5 I am going to declare as the size of the array. So for the queue empty, front and rear should be point to 0. Yes, come and stand here. So this is the 0th position. Come in front of rear. Okay, so both front and rear is now 0. There are no elements in the queue. Okay, so now I am going to fill the first element. This first element. Yeah, one of you come. Your name, Sakshi. Sakshi is going to be the first element. So she is going to by that's it. Go, that's it. Since you are placing here, I am going to have that as the first place. Okay, yes. Sit here. Yeah. So Sakshi is going to be the first data. She entered into the queue from that side. So which pointer has to be implemented now? For insertion, rear or front, rear pointer has to be implemented. So now rear and front is now both go to that side 0. So rear and front are now 0. Now which pointer has to be implemented? Front or rear? Which one for insertion? Rear end. Who is the rear end? Yeah, Piyush to point to Sakshi. Yeah, it's not pointing, just stand before you. Oh, that's it. Stand between that. So Piyush is now pointing to the first data. Okay, now second data. Now go and get inserted. Second data is going to be inserted in the queue. Again, which pointer has to be implemented? Yes. Rear or yes. Piyush has to move to the second place. Yes. Third data. Again, Piyush has to move further to the next place. Yes. Fourth data. Data. Navya. Yeah. Navya comes in. So fourth data, yes. Again, Piyush has to implement. Piyush rear end. Okay. And fifth data, come. Yeah, answer. So whenever I do the insertion, I have to check that. What condition I need to check? Whenever I do the insertion operation, whether for array implementation, whether the array is yeah, whether the array is full. If the array is full, I cannot do the insertion. So now you see the array size I declared as 5. Can I insert the sixth data? So I cannot because the array size is now 5. How will you check that the array size is 5? See the front and rear positions. What's the value for the front? What's the value for the front?
0.
Front is for deletion. Is at 0. She has to also implement and the first data has got inserted. Okay. So front pointer is now pointing to first data. Come to the first data. Okay. So whenever the first data is inserted, both front and rear has to be implemented in the first position. Okay. Now see the rear pointer. It was at 4. 4 or 5. It is not 0. The first data is at 1 only. Okay. So rear is Piyush is now at 5. So front equal to 1, rear equal to 5. The cube is full. of Q, is it not? So this is the first data. The Sakshi has to come out of the Q first. Yes, Sakshi is telling yourself. Now, front end has to be implemented. Yes, next one. Now, second data is telling that Sakshi has to implement. Okay? Yes, make. Now, again, I need to insert the one more data. Can I insert? I cannot insert because the real is equal to 5, which is the size of the array. I cannot do the insertion. But see how many spaces I have to carry. 2 spaces are free, but still I am not able to insert the data because real has reached n the size of the array. So this is the disadvantage of array implementation of any data set. So how to overcome this? How to overcome this disadvantage? Linked list. Linked list implementation is different one, okay? I'm asking using arrays itself. We have to shift all the elements. No. I can go for circular queue. I can go for circular queue to overcome this disadvantage. So I will come to circular queue afterwards. Okay. Now come to deletion. Is third data gets deleted. Okay. Front has to implement. Fourth data has to be deleted. Yeah. So again front comes to the fifth element. Now what about the number of elements in the queue? Only one element. See the front and rear positions. Both point to the same location. So whenever front equal to rear, I can say that there is only one element in the queue. Wherever be the location, if front equal to rear, there will be always only one element in the queue. Okay? So is it clear to you? Is any doubts? So to overcome the disadvantage, we go for circular queue. Okay? Queue. Okay, you will see the demo with the help of my students. Yes. Okay, for linked list, there should be one header to denote to the list, is it not? So imagine that I am the header. So initially when the queue is empty, both front and rear should point to the header. Okay? So who is going to be the friend? Aviral will act as the front pointer. Mohita will act as the rear pointer. Okay? So rear pointer for insertion or NQ operation. Front pointer for DQ operation. Okay? So initially, so the queue is empty and the header. So both front and rear will be pointing to the header. Yes, point to me. Yeah. Result. Switch my shoulder. That's all. So the first data is going to get inserted. So is going to be first data. Yes, come. Your Nitish. Giri, yeah. Giri is going to be the first data. So what should be the pointer operation? Okay, what type of linked list I am going to use? Tell me first.
Q.
Q is the data set you are going to implement using linked list. Single linked list or double linked list you are going to use? Double linked list. Why?
Linked list.
Why not single linked list?
Ma'am, because both the front and the rear and
We have to be insertion at one end and deletion at the other end. So we have to keep track of both the previous element as well as the successive element. So I need to use double linked list. Okay. So first data is going to be Giri. So headers. Header, how many links I have now? Left link and right link. Okay. So my left link should be empty and my right link should point to the first data. So first data is Giri. Okay. Now Giri's left should point to
the rear.
header. Yeah. No.
Use this hand.
Yeah, use this hand. That's all. You don't have any idea. Yeah. Yes.
Point finger.
Okay. Yeah. So first data. Okay. Second data. Now what about the front and rear? First data got inserted. Rear has to point to the first data. So how will you change the pointer connection? You come to the front or rear? No. Here, Mohita, come here. Mohita is pointing to me now. So now Mohita must change to first. Go on this side. Stand here. Yeah. Point to Giri. Yeah. Pointed to Giri. Okay. Yes. Next. Second data. Yeah. So how many points? No. Come here to Giri. So Giri's one hand must point to. What's your name? Heman. And Heman's one hand must point to Giri. So two codings you have to write. 2 lines for the pointer connections, and then again rear. Mohita has to change to second data. Heman. Okay. Yes. Third data. We see just change the pointer connections. Yeah. Fourth data. Yeah. Fifth data. Do the pointer connections. Yeah. And the fifth data's one hand should be null. He is not pointing to any sixth data. Can I insert the sixth data here? Why? Can I do insertion of sixth data? Any number of data can be inserted because it is a
Dynamic.
linked list. How will I get the nodes? How will I get the free nodes? Yeah, you forgot everything. Using, how will I allocate nodes for storing the data? Yeah. Dynamic memory allocation. Which function I will use?
Malloc.
I will use malloc as long as free nodes are available in the memory bank. I will use them for insertion. So any number of nodes can be inserted. Okay. Now what about the front and rear? You see, front is in the first. No. Whenever the first data is inserted, front and rear both must point to the first data. Okay. Yes, rear is at the last data. Now how the deletion has to be done? How the deletion has to be done? From the front end, is it not? Front end is here. So first data to be deleted. First in, first out. So yes. How do I change the pointers? How do I change the pointers? Yeah. You have to. Yeah. Both the connections of the first data will be deleted. So myself I have to point to the first data's right link. Okay, I will point to the first data's right link, and front will be, you come to the front. Aviral. Aviral is now pointing to the next data. Okay. How the second data will be deleted? Then you remove your pointers to go. Then how to touch the third data. So right link of the second data I have to move. Enter. Okay. Yes, third data. Yes, fourth data. Fifth data. Fifth data got deleted. Yeah. Again, front and rear must point to header. Clear? So any doubts on this? Okay. So imagine that demo what we have seen in the class. So see the algorithm. So what is the first point? We have to check whenever insertion has to be done. We have to check whether the cube is full or not. If the cube is full, we cannot do the insertion. So how will you check whether the cube is full? So rear should be equal to n. So if rear has reached the capacity of the array, then the cube is full. You will display that. You cannot do NQ operation. Otherwise, what we have to do? We have to check whether that is going to be the first data to be entering into the cube. The first data means they have to, both rear will be 0, front will be 0. So if that is going to be the first data, front has to also be pointing to the first data for insertion. So front will be equal to 1, rear will be equal to 1. Otherwise, if that is not going to be the first data, which pointer you have to move, front or rear? For NQ operation, you have to always increment the rear pointer. So rear should be equal to rear plus 1 and then you have to place the data in the location specified by the rear pointer. So this is the ordinary NQ operation in a queue. Whenever you want to insert the data, the rear pointer alone has to be incremented. If that is going to be the first data, both front and rear should point to the first data. Okay? For DQ operation, you have to disturb the front pointer alone. Okay, again you have to check whether the queue is empty before doing the deletion operation. So the queue is empty, you cannot delete. So how will you check whether the queue is empty? So front is equal to 0, I can say that queue is empty. You cannot do DQ operation. Otherwise, you have to check whether take the data specified by the front pointer, then you are checking whether that is going to be the single element in the queue. There is only one element in the queue. We have seen that front will always be equal to rear. We are checking whether that is going to be the single element. That happens to be the single element. After deleting the single element, both front and rear should point to initial 0 position. Otherwise, if there are more elements in the queue, more than one element in the queue, we have to just increment the front pointer alone for DQ operation. So is it clear to you? Is it clear? Then using linked list, just now we have seen, is it not? So see the coding. So I have to use double linked list. Initially when the queue is empty, both front and rear will be equal to the header, and then see the header's right link will be pointing to null, nothing. And for the queue has at least one element means the header's right link will not be null. So if it is null, the queue is empty. The header's right link is not null, the queue is not empty. It has at least one element. Now come to the insert operation. So initially I am assigning the pointer to the header. I am naming the header as pointer, and then I am checking whether the queue is full or not. So here when the pointer's right link is not null, what I am doing? I am moving the pointer to the right side. So how long I have to do till I reach the end of the queue? So I reach the end of the queue. Now PTR points to the last element in the queue. And then you are doing this get node is for dynamic memory allocation. But actually in coding you will be using MLR. Okay? So new is for the new node. If new node is available, that is the meaning of new not equal to null. If new node is available freely, then go for insertion. If the new node is not available, if free node is not available, then I cannot do the insertion. So if the new node is available, what I have to do? 3 pointers need to be changed, is it not? Both left link of the header, right link of the header, left link of the new node, the right link of the new node should be made null, and then you have to place the data in the new node. So 4 lines. Understood? Otherwise, print insertion is not possible if new node is not available. So understood? So I think you can go for the DQ operation. DQ operation is check the diagram. Check the diagram. Which one has to be deleted? This is by the shown by the front element. First in, first out. So this is the first element inserted. So how will you change the pointer connections? So PTR has to be deleted. So what I am naming the first node as PTR. I am naming the second node as PTR1. So PTR has to be deleted. So the header's right link now point to PTR's right link. PTR1's left link must point to header. So automatically PTR will get deleted. Now see the pseudocode. So you have to check. The first node is named as PTR, header's right link. So if the header's right link is null, you cannot do the deletion. The queue is empty. Otherwise, if the queue is not empty, you are naming the second node as PTR1. When you are doing you are changing the pointer connections, and then you are returning the deleted node to the memory pool. That is the return. Okay? Is any doubts in this? Now what is the disadvantage of array implementation we have seen? Memory space we have seen. As we see this diagram, what is the size of the queue? 10. How many elements are there in the queue? 2 elements. So front and rear positions you check. Front is at 8th position, rear is at the 9th position. So this is the current status of the queue. Imagine. Now come to the next diagram. You need to perform a DQ operation, that is division. So which pointer I have to disturb? F has to be disturbed. So F has to be incremented. Now next operation, NQ. So I have to add one element. So a new data is placed at the 10th place. So R has to be incremented. Rear pointer has been incremented. Now next operation is NQ. Can you do it? I cannot do because R has reached, R is equal to 10, the full size of the array. So what I have to display? Q is full, you cannot do NQ operation. Now next operation is DQ. So again, F has to be incremented. So 9th data is deleted. Okay. Now see the next operation. Again DQ. Now only one element in the queue. Front equal to rear. So what I have to do? Both front and rear has to be made to 0. So the 10th data is deleted. Both F and R now points to 0. Next operation. Again DQ. Can I do? I cannot delete anything because the queue is empty. So it has to display as queue is empty. Now next operation. NQ. Queue is empty. That is going to be the first data. So place the data in the first place. Both F and R has to be incremented. Okay. Next operation is NQ. So again rear has to be incremented. Next operation is DQ. F has to be incremented. Next one is DQ. Only one element. So delete the element. Both front and rear has to be moved to position 0. So is the operation clear to you? NQ and DQ operation. So the disadvantage is even though space is there. Now you see here, there is a queue is full, is it not? Out of 10 spaces, 8 spaces are empty. Only 2 spaces are occupied by the data. So even though 8 spaces are free to be occupied, I cannot do the insertion. So to overcome this disadvantage, I go for circular queue. See the diagram? So circular queue nothing but the last index of the array is going to be adjacent to the first element. So imagine that as a circular queue. So how will you implement this? So after n, the next position will be, it is not n plus 1, that is going to be 1. That is the meaning of circular. Got it? Me for you I am asking. Yeah, Divi only na? Yeah, I remember your name. So, how will you do the increment now? After n, it should not be n plus 1, it should go to 1. So, which operation I am going to use? So, instead of just incrementing front equal to front plus 1, rear equal to rear plus 1, I have to use this formula. What's the formula? Any point of any position to shift to the next location, I have to use I mod length plus 1, where I can refer to either front or rear. Length refers to the size of the array, what you have declared. MOD stands for mod. Which operation? Modulus operation. So what is the result of modulus operation? 5 modulus 4. The answer is modulus operator will always return the remainder of the division operation. So 5 modulus 4 means 1. 5 modulus 5 means the answer will be
0.
So instead of front equal to front plus 1, I have to use front equal to front mod size of the array. Instead of rear equal to rear plus 1, I have to use rear equal to rear mod size of the array. The same coding of the circular implementation using array, queue implementation using array, the same coding you can use Just these two lengths has to be changed. Instead of normal addition, you have to use modulus operator here for incrementing the front and rear pointers. So the same pseudo code, what we have seen now, there won't be any change. Instead of rear equal to rear plus 1, I have to use rear equal to rear mod length plus 1. Here, instead of front equal to front plus 1, I have to use front equal to front mod length plus 1. Okay? Here also to check whether the circular tube is empty, the same condition. Front will be 0, rear equal to 0. And to check whether the tube is full, circular tube is full, we have to use this one. Front equal to rear mod length plus 1. So this to check whether the circular tube is full. So the same things. So here this will be the change. Okay, the same coding you can use. So we need not go through it. Now see the diagram. You can understand it better. So initially, what's the size of the array? What's the size of the array here? 4 is the size of the array. Initially, the cube is empty, both front and rear pointing to 0. Now see NQ operation. You have to insert A. So A is going to be the first data. So both front and rear will be pointing to first one. Okay. What formula you have to use? Front equal front mod length plus 1. What is front? Front is F is 0. F equal to 0 mod 4 plus 1. What is 0 mod 4? 0. 0 plus 1 1. So F equal to 1, the same for rear or equal to 1. Understood? Now come to the second one. Again in circle. We have to insert B. So B is going to be inserted as the second data. So I need to disturb only rear point. Next, C is inserted. D is inserted. Now the Q is full. Next for DQ. So the first data to be deleted. So I have to disturb F, pointer F. Now apply the formula. F is initially 1 mod 4 plus 1. What is 1 mod 4? 1 mod 4 is? What is 1 modulus 4? Don't know.
0.
Huh?
0.
1 only. To divide 1 by 4, what is the quotient? What is the remainder? 0 is the quotient. What is the remainder? So modulus operator will always return the remainder of the division. Okay. So 1 modulus 4 is 1 plus 1 will be 2. So F is now incremented to 2. Okay. Next is the see one space is free now. I have to insert E. How will you do that? Again I have to increment rear. So what is rear now? R is equal to 4. 4 mod 4 plus 1. What do you get? 0 plus 1, that is 1. So at position 1, E got inserted. Now see the disadvantage is overcome now. One space is available. I am able to insert my new data into the array. Now DQ. So second data is deleted. F is incremented. Then again the second place NQ of F. Again in the second place in the empty second space I am inserting new data using the same thing. R equal to R mod length plus 1. Then here, yeah, 2 modulus E. Initially F is at, sorry, R is at 4 now. So R is NQ of E here now. Initially R is at 4. Yeah, here. Okay. DQ means here this is deleted. A is deleted, front is incremented here. Next is E has to be incremented, E has come here. So you have to check this one, R alone. Yeah, F is at the same place. Okay. Then here, DQ. So this is going to be deleted, front will be incremented. Then NQ. R has to be incremented. So 1 mod 4 plus 1 will be 2. So R will be here. In here, deletion. So F has to be incremented. Then again deletion. D will be deleted. F. See, what is the formula now? 4 modulus 4 plus 1. It will be 1. So F is now at the first place. Next, again deletion. F has come. See, only one element in the cube. So after deleting the single element, both front and rear has to be 0. Is understood? Yeah. This will stop here. Rules 1. Double-ended cube. What do you mean by double-ended cube? Double-ended? So already it is double-ended only, is it not? One end I have done the insertion, other end I have done the deletion. If I am able to do both insertion and deletion at both the ends, then that becomes the double-ended cube. Okay? So this cube can be used as a stack also. How? Stack at only one end you can do the insertion and deletion. So I can take any one end, instead of front or rear I will name that as top, I will do the insertion and deletion. So it can be modeled as a stack also. It can be modeled as a cube also, insertion at rear and deletion at the front. It can be used as a double-ended cube, both insertion and deletion at both ends. Okay? So use the appropriate names. When it is used as a stack, use the names push and pop. When it is used as a normal queue, use it as NQ1, Deque. Okay? And there are two types of input restricted DQ and output restricted DQ. Two types of double-ended queues, input restricted and output restricted. So what do you mean by input restricted? Input means data entry. Data entry is done at which end? Rear end, is it not? So at the rear end, only insertion is allowed. If at the rear end, if you allow only insertion. If at the front end, if you allow all the both insertion and deletions, then that is known as input restricted. Okay? Output restricted means? Output means the data exit. Data exit is from the front end, data deletion. So if you restrict the front end, only deletion is done at the front end alone. In the other end, if you can able to do both the insertion and deletion, then that is the output restricted double-ended cube. Okay? So double-ended cube can do insertion and deletion at both the ends if you restrict any one operation. If you restrict the deletion at the front end, then that is the output restricted DQ. If you restrict insertion alone at the rear end, then that is known as the input restricted. Okay? And one more queue was that priority queue. Would have come across this queue in your CPU scheduling algorithms now? Priority scheduling. What is the meaning? Priority scheduling. So all the jobs will be put in a queue. Each and every job will be allocated a priority. And how the jobs will be allocated to CPU? CPU will be allocated to the job with the highest priority. So which job will leave the queue first? The job with the highest priority. Then again, next job will be again the highest priority job will leave. So it won't follow the principle of queue. It won't follow the first in first out principle. It will follow the priority of the data in the queue. So along with the data, I have to store the priority also. And the data with the highest priority will leave the queue first. That is the priority queue. And the applications of queue. So any problem which needs to put the data in a queue, I can model it using a queue. So anything can be simulated using a queue if you need to put all the jobs or problems or anything in a queue. So best one is CPU schedule. Yes, that's all. Is any doubts in queues? So we have seen queue, then circular queue, double-ended queue, priority.